Assalamu alaikum. Welcome, dear students, to our second part in chapter 14, description of motion. By the end of this video, you will be able to describe the principle of functioning of the air table and determine the value of the instantaneous speed of a moving object. Let's review together the objectives of the previous video. We've learned that motion is relative. A trajectory is the path followed by a moving object. The space reference is a system to which all the positions are determined. The time reference is an instant denoted by t0, considered equal to 0 relative to which all other instants are determined. The position vector determines the position of a particle m in a chosen reference, where r equal to om vector equal to xi vector. The characteristics of the position vector are the origin O, the line of action which is the line holding OM, usually the x-axis, the direction from O to M, and the magnitude which is the distance or the norm of the vector OM. The average speed is calculated by dividing the total distance by the total duration of time. It is expressed in meter per second in the SI unit. The instantaneous speed is the speed at each specific instant, usually measured by a speedometer. To introduce the instantaneous speed, consider the following example. Observe the motion of the car. It's clear that the car changes its speed several times as it moves from A to B, covering a total distance of 5 km in 12 minutes. Then, to calculate the average speed of the car in km per hour, you will divide the total distance by the total duration of time. Start by converting the time into hour by dividing it by 60. This gives you 5 km divided by 0.2 hour, which gives us 25 km per hour. In fact, the average speed gives us a general idea about the speed of the body throughout its journey, but it does not inform us about the variation of the speed of the body over time in order to study its movement. So, we must find the speed in a more detailed way. That is, to find the instantaneous speed. Actually, the instantaneous speed is calculated exactly like the average speed, but with only one difference. To calculate the instantaneous speed, you need to find the distance traveled in very short intervals of time. Since during this small time interval, the object's speed doesn't express a remarkable change. In other words, when calculating the average speed in such small intervals of time, we can then say that this average speed is approximately equal to the instantaneous speed. For example, during 0.25 seconds, the car covered 1.5 meter. Then the instantaneous speed of the car is calculated by dividing the distance by the very short time, which gives us 1.5 divided by 0.25, which is equal to 6 meter per second. To express it in kilometer per hour, all you need to do is to multiply it by 3.6, which gives you 21.6 kilometer per hour. Note that to properly study and describe the movement of a body, it is important to take equal durations of time between each two successive instants. Here, delta t between t0 and t1 is 5 seconds, and between t1 and t2 is also 5 seconds. Then, in studying motion, the duration separating successive instants is usually equal. Don't forget that the SI unit of time is second, and from millisecond to second we multiply by 10 to the power minus 3. Now, how can we study the motion of a moving object and its characteristics in the physics laboratory? We will learn about the air table, a device used in the laboratory to record the positions of a moving puck. These recordings allows us to study some physical quantities like position, velocity, acceleration, etc., and then make verifications of many theorems and laws, as we will see in this year and on the next years. So, what are the main parts of this device and how does this device works? There are different models of air tables. In the model shown here, the air table consists of a table with a smooth glass surface whose feet are adjustable so that the inclination of the table can be changed, a black conductive carbon paper placed under a white paper on the glass surface, two pucks which are connected to flexible tubes, which are connected to an air pump that creates a thin layer of air between the puck and the table on which it moves. So the pucks then almost move freely without friction. There are also a copper needle at the bottom of each puck connected to a high voltage power supply called a spark timer. The spark timer produces sparks with different frequencies, different periods, that is, the time interval separating two consecutive sparks is very small and equal, and we call it tau. When the spark timer is turned on, a spark jumps from the needle of the puck to the carbon paper, leaving a black dot on the white paper. Thus, the moving puck leaves a trace of black dots showing its actual path. The study of these dots enables us to measure the distance traveled between two consecutive positions. Note that in our case, when the table is horizontal, the distances are equal. And knowing from the spark timer the duration between two consecutive points, which is the same and equal to tau, then we can calculate the average and instantaneous speeds of the puck to use them in several fields related to motion studies. Note that when we regulate the inclination of the air table, the table will become inclined. In this case, we can notice that the distance separating two consecutive positions are not equal anymore, and in this way we can study another nature of motion. We conclude from the video that the air table can be used to study different types of movement, record successively during equal time interval tau the different positions occupied by the puck during its movement in the form of successive dots. These dots represent the trajectory of the moving puck. But how can we analyze the results given by the air table to calculate the average and instantaneous speeds? Consider the following records given by an air table. We denote some successive positions from the initial instant t0 by m0, m1, m2, m3, m4, and m5, where the time interval separating two successive positions is constant and equal to tau, where tau is equal to 50 milliseconds. The average speed of a moving object between any two instants ti and tj is given by the average between I and j is equal to the absolute value of delta x divided by delta t, which is equal to xj minus xi as an absolute value divided by tj minus ti, which is equal to the distance between mi and mj divided by tj minus ti. Let's take the following example. To calculate the average speed between the instant t0 and t5, we divide the absolute value of delta x by delta t, which is equal to the absolute value of x5 minus x0 divided by t5 minus t0. In other words, the average between the instant t0 and t5 is equal to the distance between m0 and m5 divided by t5 minus t0. But the time interval between any two successive positions is the same and equal to tau. Then, between m0 and m5 we have 5 tau, and each one square corresponds to 1 centimeter. Then the distance between m0 and m5 is 15 centimeter. Then the average speed between the instant t0 and t5 is equal to 15 centimeter divided by 5 tau, where tau is equal to 50 millisecond. From millisecond to second, we multiply by 10 to the power minus 3. This gives us 0.15 meter divided by 5 times 50 times 10 to the power minus 3 second, which gives us 0.6 meter per second. The instantaneous speed Vi of an object at any instant Ti is approximately equal to the average speed of this object between the two instants Ti minus 1 the instant directly before it and Ti plus 1 the instant directly after it. It is given by Vi equal to V average of I minus 1 and I plus 1, which is equal to the absolute value of delta x divided by delta t. This gives us the absolute value of xi plus 1 minus xi minus 1 divided by ti plus 1 minus ti minus 1. Note that this is simply the distance between the positions mi minus 1 and mi plus 1, and this duration of time is always equal to 2 tau. Let's take the following example. To calculate the instantaneous speed at the instant 2, it is simply equal to the average speed for the instants just before it and just after it, which are the instants 1 and 3. Then V2 is equal to absolute value of delta x divided by delta t, which is equal to the absolute value of x3 minus x1 divided by t3 minus t1. This can be simply written as the distance between the positions m1, m3 divided by t3 minus t1. As we have mentioned that the duration of time between the positions m1 and m3 is equal to 2 tau, and the distance separating them from the figure is equal to 5 centimeter. By substituting, we obtain 0.5 meter per second. Let's practice by solving the following application. But before we start, don't forget to pause the video and try to solve it by yourself. The Airtable recorded the positions of epoch P at 8 instants, T0, T1, etc. till T7. The puck started from O at T0 and moved horizontally to the right. T0 is taken at the time reference, and the time between two consecutive instants is tau equal to 100 milliseconds. Note that each one square corresponds to 5 millimeter. In the first question, you are asked to calculate the average speed of the puck between the instants T3 and T7. Then, V average of 3,7 is simply equal to the distance separating P3 and P7 divided by delta T. You can simply count the distance as 5, 10, 15, and 20. Then the distance is 20 millimeter divided by 1, 2, 3, and 4 tau, which gives us 800 milliseconds. 20 divided by 800 gives us 0.025 meter per second. Here, note that from millimeter to meter, we multiply by 10 to the power minus 3, and from millisecond to second, we multiply by 10 to the power minus 3. Then, simply, if we divide millimeter by millisecond, we obtain the unit meter per second. In the second part, we are asked to calculate the speed of the puck P at the instants T2 and T5. When calculating V2, we will calculate the average speed between the instant directly before it and that immediately after it, which means that we calculate the average speed between the instants 1 and 3. Then it is equal to the distance P1, P3 divided by 2 tau, which gives us 10 millimeter divided by 400 milliseconds, which is equal to 0.025 meter per second. Similarly, V5 is equal to the average speed between the instants 4 and 6. Also, by replacing each value, we obtain 0.025 meter per second. Observe the motion of the two cars. They are moving with the same speed, they cover the same distance in the same duration of time. But what is different between the two motions? Yes, it is their direction. Actually, the speed is a scalar value. It indicates the magnitude without taking care to the direction of motion. But in studying motion, we need to describe both magnitude and direction. To do so, we will use a vector quantity which we call velocity. So, the speed is always positive. That's why when calculating its value, we write V equal to the absolute value of delta x divided by delta t. Whereas in the case of velocity, V is the algebraic value of the velocity vector. It could be positive or negative, and its value is equal to delta x divided by delta t. In the previous slide, we've mentioned that the algebraic value of the velocity vector could be either positive or negative. This helps us in recognizing the direction of motion. If the object moves in the positive direction, like in this case, we notice that the abscissa increases, which implies that delta x is positive, and in this case, V is positive. On the other hand, if the object moves in the negative direction, like in this case, we notice that the abscissa decreases, which means that delta x is smaller than 0, which gives us that the algebraic value of the speed is negative. Then the sign of V indicates the direction of motion. The velocity vector of an object in rectilinear motion is given by the vector v vector is equal to vi vector. The characteristics of the velocity vector in rectilinear motion are the origin, which is the position of the object at the given instant, the line of action, which is along the trajectory, the direction in the direction of motion. It is positive if the object moves in the positive direction of the axis, and it is negative if the object moves in the negative direction of the axis. Magnitude, which is the speed of the object at the considered instant, which is equal to the norm of the vector v. Now let's practice by solving application 2. The figure below represents the motion of a puck drawn to real scale, where tau is equal to 60 milliseconds. This is the time interval between two consecutive positions. Find the instantaneous speed at m4. To find the instantaneous speed at m4, we need to calculate the average speed between the instants t3 and t5, the one directly before it and the one directly after it. Then v4 is equal to v35, which is equal to m3 m5 divided by delta t, which is always in this case 2 tau. To calculate the distance m3 and m5, since the figure is drawn to real scale, then all you need to do is to bring a ruler and measure the distance between m3 and m5. In our case, this distance is equal to 6 centimeters. Replace it in the formula, 6 centimeters multiplied by 10 to the power minus 2 to convert it into meter, divided by 2 times 60 milliseconds multiplied by 10 to the power minus 3 to convert it into second, gives us 0.5 meter per second. Now you are asked to give the characteristics of the velocity vector v4 at the position m4, then represent it. The origin of v4 is the position m4, the line of action is horizontal, the direction is to the right with the direction of motion, the magnitude is the speed v4, which was calculated in the previous part, and it is 0.5 meter per second. Now to represent it, we need to choose a scale. I will choose the scale. Each 1 centimeter corresponds to 0.25 meter per second. Applying the cross multiplication rule, we obtain 2 centimeters. Now we can draw the velocity vector v4 at m4 directed to the right of length 2 centimeters. In this video, we've learned that speed is the rate of change in position as a function of time. The average speed is calculated by dividing the total distance by the total duration of time. The instantaneous speed is calculated by dividing the total distance covered in a very short interval of time by the total interval of time. The characteristics of the velocity vector is the origin, which is the position of the object at the given instant, the line of action, which is always along the trajectory, the direction is in the direction of motion. If v is positive, then the object moves in the positive direction of the axis, and if v negative, then the object moves in the negative direction of the axis. And finally, the magnitude, which is the speed of the object at the considered instant, calculated by calculating the norm of v vector. This is the end of part 2. Thanks for your attention.